Now we are going to do a dopamine drip, and we're going to do a long drawn out version, and then we're going to do a short version also. The long version is so you understand why the short version works. So here we go. Our order is to give 8 micrograms per kilogram per minute. Now, when you see the 3 lines here, that doesn't mean that you're dividing 3 separate times. It just means that there's two equations that need to be solved for. That's all. Patient weight is 220 pounds. So first thing we do is always make everything like units. So 220 pounds is 100 kilograms. So now we're going to bring down our order. 8 micrograms per kilogram, so I'm going to multiply it by that 100. I don't need the kilograms anymore, so I'm going to drop that unit. Okay, so I have 8 micrograms times 100, because that's my kilograms, and then that's going to be over the 1 minute. So 1 minute, and then this is going to equal 800 micrograms every 1 minute. So now this is our desired dose. This is what we want to give the patient. So now we're going to start lining up our sequence right here. 800 micrograms every minute, every 1 minute. This is our desired dose, times our dose on hand. Remember, for dopamine is always going to be the 1 milliliter in 1600 micrograms, or 1600 micrograms in 1 milliliter. Since I have micrograms on the top over here, I'm going to put it on the bottom over here so it can cross cancel. So 1600 micrograms over 1 milliliter. So I've got my desired dose and my dose on hand. And now we need to keep going, and we're going to do our delivery section. So delivery. For our delivery of dopamine, we always use a 60 drip set. So 60 drips is 1 milliliter. I have 1 milliliter on the top over here. So I need to put the milliliters on the bottom over here so it can cross cancel. 1 milliliter, and then said 60 drip set. So I'm going to go ahead and solve this the way it is, and that's going to give me my answer in minutes. Okay, so I'm going to cross cancel. I don't need my micrograms anymore. Cross cancel micrograms. Cross cancel milliliters for milliliters, so I'm left with drips over minutes. Okay, so all the numerical values are still active, but the units themselves are what gets cross canceled, as long as they're like units. So 800 times 60 is going to give me 48,000 drips in, I still have my minutes, so 1 times 1600 times 1 is going to be 1600 minutes. And then from there we are going to divide, and so 48,000 divided by 1600 is 30 drips, because we're continuing our units. 30 drips over 1 minute. So if your test answer is asking for how many drips per minute, this is your answer right here, 30 drips per minute. Now in real life, we're not counting per minute, we're counting in seconds. So now we're going to deduce this a little bit further, and we're going to add a time section in here. So I have my minutes on the bottom, so I'm going to have 1 minute on the top here. and 1 minute has 60 seconds. And then from there, we are going to cross cancel 1 minute and 1 minute. This gives me 30 drips in 60 seconds. And then after that, we just continue to deduce it. 30 goes into 62 times, so 1/2. So we have 1 drip every 2 seconds. So this is our real life answer. This is how we're going to set up our drip. And this is our potentially our test answer question. Whenever I did med math tests, I always put both answers down, just to make sure the instructor understood that I kind of knew what I was talking about, I guess. So that was our long way to do it. I'm going to write out the entire equation, including our time sequence, and I'm going to show you how much stuff actually cancels out when we go ahead and add in our time sequence. So 800 micrograms over 1 minute. It's our desired dose. Dose on hand, delivery, time. Okay, so then my dose on hand is 1 milliliter over 1600 micrograms. Again, remember being able to cross cancel. My delivery, we're doing 60 drips, still 1 milliliter in that. And then my time sequence is going to be 1 minute, because my minute over here is on the bottom, so 1 minute over 60 seconds equals. All right, so now I can completely cross out the milliliters, 1 milliliters, because there's like units and like numbers. 1 minute, 1 minute, those can completely go away. Now, I have 2 numerical values that are the same. My units are different, but the numerical values are the same. So I can actually get rid of the numerical values. That way they're no longer part of the math equation part, but the units with them have to stay. Okay? And then we're going to come back over here. My micrograms can go and my micrograms can go. So all of this, the only things I have left are 800 drips, TTS, and then 1600 seconds. So if you look at it, it's the exact same thing, because 800 goes into 1600 twice. So this still equals 1 drip over 2 seconds. Now, to get rid of all this, all we really have to do is take our micrograms times our kilograms divided by 1600, and that will give us our drips over 1 second. And it does work every time. The numbers aren't always as pretty, and we're going to do another problem where the number doesn't come out as nice as the 1 drip per 2 seconds, but this is what you can do in the field super fast and get your drips per second. If you need to get your if you want to use this equation but you need in drips per minute, all you have to do is micrograms times kilograms times 60 divided by 1600, because there's 60 seconds in 1 minute, and then that's going to give you our drips over 1 minute. So again, you can use both of them, but all of this hoopla can be done right here. So we're going to do another dopamine drip. Okay. Dopamine drip. Our order is, say, 6 micrograms per kilogram per minute. Patient weight. Let's just stick to 100 kilos just to make it a little bit easier on us. So again, not 3 division problems, just 2 equations. So we're going to have our 6 micrograms, and then it's multiplying by the kilos. We know it's 100 kilos. I don't need the kilos units anymore, so I can drop the kilos. So 600 micrograms times 100 every 1 minute. So then this equals 600 micrograms per 1 minute. This is our desired dose. So we're going to bring our desired dose down here. 600 micrograms over 1 minute times our dose on hand, and our micrograms on the top. So we're going to do 1 milliliter over 1600 micrograms times our delivery. And our 1 milliliter is on the top, so 1 milliliter is going to go on the bottom now, so we can cross cancel. 60 GTTS. And then we'll keep it there for now so we can get our answer in minutes. So we're going to cross cancel our micrograms, so our units are units. The milliliter, the 1 milliliter, that can completely go. And so now we are left with drips over minutes. So 600 times 60 equals 36,000 drips in 1600 minutes. And so when we divide these into each other, it gives us 22.5 drips in 1 minute. So that's our test answer number 1. If we want to divide this down, if we want to get our seconds, we would do 22.5 drips over 1 minute. 1 minute goes on top, and then 60 seconds on the bottom. And then this would equal, cross cancel. So then we have 22.5 drips in 60 seconds. We're going to divide this, and it's going to give us 0.375 drips every 1 second. Okay, so when our numbers are not as pretty and workable, we need to make them that way because we're in the field, we don't have pumps, or at least not where we are, we don't have pumps, and we need to make this to where we can physically get the drip set. Now, there's no way for anybody to calculate 0.375 drips every second. That just is not something that we can do. So what we can do is make these terms something that we can manage. So let's just round this up to 0.4. And what we're going to do is we're going to have 0.4 drips per 1 second. Now I know if I multiply this by 3, that'll give me a little bit over 1. So anything I do to the top, I need to do to the bottom. So I'm going to multiply this by 3, multiply this by 3, and this will equal 1.2 drips every 3 seconds. I'm going to drop the 0.2, so then my answer is 1 drip every 3 seconds. So is it the perfect, beautiful math that this is? No, but this is something that we can work with in the field.